Hello everyone, welcome to the video. I will be covering SLO number 15, which is determining the number of different oblique triangles that exist given certain side lengths and angle measurements. Number 16 will be a part 2, but I'm included in this one here. It's because you kind of use both here, using the laws of sine and the law of cosine to solve oblique triangles and be determining all missing side lengths and angle measurements. So for number 1, we have B equals 47, A equals 23. These are all side measures, by the way. Angle A, which is 137. So from here, we could use the laws of sine because we have angle A and side A. We would use cosine, the laws of cosine, if we just had side, side, side. Or if we had like the angle of C, which we wouldn't be able to solve it here. So from here, we could do 23 over the sine of 137 degrees will equal 47 over the sine of B. And then from here, we could cross multiply 23 by sine over B. And then we can also cross multiply 47 by sine of 137. This, the main goal here is to have B by itself, which we will divide by 23 here. And as well as the other side, because what you do on one side, you got to do on the other side. And the main goal here is to get B by itself. Yeah, that's a bad 3. So we could use the law of sine, which is here, which was what I was starting to do here. Should have probably put that beforehand, but there's A in relationship, angle A in relationship with side A. So from here, we could just simplify this, and that's I kept going. I didn't think it was going to look. It doesn't look too bad. So sine B, when you simplify 47 sine of 137 degrees over 23, you get 1.39. And, a lot more points there. It wasn't necessary, but I kept putting them in there so I could have a more accurate reading for B. And here we would be dividing by sine from both sides, because what you do at one side, I got to do to the other side. This is just further down. We're trying to get B by itself. Again, this here will be the same thing as multiplying by sine negative 1. Well, I got sine to the power of negative 1. Sorry. From here, you can already tell you're going to have a domain error due to the sine's domain is from negative 1 to 1. This is over by 1. So here we're only going to have one triangle due to the measurements chosen or the measurements given. There's no way we can have a triangle with those measurements. Now, for number 2, we have C, which is side C, 34, side B, which is 18, and the measurement for angle B, which is 25. Here, again, we have angle B with side B, which allows us to use laws of sine. In this case, use the law of sine of B and the law of sine of C to solve this. So we got 18 over the sine of 25, which was given, over 34 over sine C, which is what we're looking for. So here we could cross multiply like we did in the last problem, which gives us 34 times sine of 25 and 18 times sine of C. Again, C is what we're looking for here. So from here we could divide by 18. And what you do on one side, got to do on the other side. So dividing by 18 in both sides, we get sine of C equals 34 sine of 25 degrees over 18. When simplifying this, will give you to sine C equals 0.798279 again. From here we divide by C, which I skipped over just to see that when you divide by sine, it's the same thing as sine to the negative power of 1, which is one of the reciprocal properties, I guess you could call it. This here will give you 52.97. We figure out that we have, how do we figure out that we have 2 triangles or more? Or what, 2 triangles, 1 triangle. We will be subtracting by 180 and what we found here for C, which we get 127.97, or 127.03. Don't know where I get, oh, that's where I got the 97 from. Here you're going to add 25 to it, which gives you 152.03. And we could, obviously that's way lower than 180. So here we could tell we have 2 triangles that exist in this problem. Let's solve for triangle 1, which we're doing up here. So we could add 25 degrees with 52.97, which we found here, gives us 77.97. You will subtract 180 by 77.97, which gives you 102.03, which here will be angle A. We have, we're looking for side. Well, that went over too far. Looking for A now. So we can be using A, and we're going to be using the sign of C this time. Let's put it this way, so much easier to recognize. So A over sine of 102.03 degrees will equal 34 over sine of 52.97. And you will cross multiply here again like we were doing the previous problems. And if you probably haven't realized yet, I'm not very good in this whole drawing thing. I type most of it. I'm just trying to make it easier for people to understand. But so here you will get 34 sine of 102.303, sorry, over sine of 52.97. A heel equals 41.6541. So for this triangle, which is triangle number 1, you would get A equals, angle A is 102 degrees, which what we found up here when we subtracted it. Angle B, which is what we found up here. Well, let's see. Oh yeah, angle B was given. Yeah. So I'm all confused here. Angle C, which we rounded to be 52. Angle A, well, side A, we found it here. Side B was given, as well as side C. Now for triangle number 2, and yep, this is the reason why I decided not to use this one. So let's see. Let's just erase all this stuff out of here. That way we can have a clear canvas again. Yeah, I wish I deleted it. I don't know why I kept it. So from here we have triangle 2, which again we found C1 for us will be the 127 we found by subtracting the C that we found from the other one. It was the 52 from the 180. So from here we go back to the pen. From triangle 2 we will have C1, which is 127 is our new, and then from here add 25 to it will be 52. Subtract the 180 gives us this, which is the new A. So from here we could do the laws of sine, cross multiply it one more time here, as well as here. It gives an A times the sine of 25, which I just skipped the whole step because time is kind of running a little bit slow. Now I got another example to catch up. So A equals 18 sine of 27.97 and over 25, which well, I guess you could have skipped the A part. So from here, this will give you A, which is 19.97. For triangle 2, we have angle A, which is 28. Just write it up here. Angle B, which was given. Angle C, which we found. That's how we got this second. There's two triangles exist. Angle A, well, side A is 20. Side B is 18 was given, as well as side C, which is 34. For the next example, we have A equals 18, C equals 32, and the angle C equals 133. Using the laws of sine, we have 18 times the sine of 133, as well as sine A times 32. This we divide by 32 here. Do what we do on one side to the other side. This is not very good handwriting. So we have sine A over 18 sine 133. Simplify this, gives you sine 0.44. Divide by sine both sides, you get the reciprocal of sine to the -1, which this would be 24.29 degrees. If you subtract 180, which gives you 155.71 degrees. If you add it to the 133 degrees, it will be too big, so only one triangle exists in this example. Here we add the angle that we found, and then we subtract it by 180. We find that's the angle for, what's it called, the angle for B. Here we cross multiply, and then we have, looking for B, which is what we found B here, to be 16.89. So for this triangle, we have angle A, which was found up here, angle B, and angle C, which was given. A and B, and time is running out, but you can see here's what we found.